Alright, so we're going to be looking at trig identities with the unit circle. So the unit circle basically kind of translates the angle into trigonomic ratios uh, like we have here, and then we have 3 pi by 4 for 135 degrees. So unit circle just shows all the basic ones. You're not really going to be using any other ones besides these. So I guess we can start with our first question. 2 cosine x minus 1 is equal to 0. So this one you can solve with basic algebra. Cosine x minus 1 is equal to 0. So I have 2 cosine x, and you can add 1. You can divide by 2. Now, since we're looking for the x value, you might just think we can just divide cosine, right? But one thing with cosine is that and sine, tangent, all of that, is that it always needs a value next to it. So you can't divide it. It always needs a value. It can't be empty. So so we have to keep it, because if we divide it, it'll be 1/2 over cosine. It'll have no value, which is untrue. That can't happen. So we'll just continue with cosine x is equal to 1/2. So we're looking at our x values with 1/2. So we have this one, which is this is our y value. So this would not be it. We pi. This is pi over 3 because our x value is 1/2. So pi. Let's go through here. 5 pi over 3. Now note our domain is sorry, now our interval is 0 pi to 2 pi. So the entire circle is 2 pi. So this would be pi, half pi or pi over 2, pi, 3 pi over 2, then 4 pi over 2, which is 2 pi. So that's our full interval. If our interval was from 0 pi to pi over 2, then we'll only have pi over 3 because this would be our interval. So we can only grab our values from this quarter, like this. But if it was uh, 0 pi to 1 pi, then we would have all of this to grab values from. So that's how you get the value. Now let's go on to the second one. Oh, okay. Our second one says sine 2x is equal to cosine x. So the first thing we can do is sine 2x minus cosine is 0. Now if you look at your trig identity sheet, if you have one, but there's plenty online, uh, once you convert the identity, you get negative cosine x is 2 is equal to 0. Okay, so it's a little hard to read, but that's what it shows. Next, you can isolate cosine from this. So, because both of them contain cosine, so you can do cosine of x, and then in a bigger parentheses, put these values, because you're taking away one cosine. So at the end, we'll just have, so this one will go outside. So we'll have parentheses here. This one will go outside. So we'll have 2 sine, um, 2 sine x minus 1, because of this cosine x being gone. 2 sine x minus 1 is equal to 0. Now, for these two values, this one has to be 0, and this one has to be 0, in order to achieve 0. So cosine, uh, cosine x is equal to 0, which is pretty simple. So what x value is equal to 0? Well, we have 3 pi over 2 and pi over 2. Because this x value right here is 0. So our answer would be pi over 2 5. Now for 2 sine x minus 1, we're basically doing the same thing as we did in this one, except instead of cosine we have sine, so this means we need the y value. So we'll have sine x is equal to 1 half. So we'll have to find y values which contain 1 half. So if we go through, we have pi over 6 and 5 pi over 6. And those are only 2 values. So that means that we solve it for that one. So we left, so our next value is over 6. And, alright, thank you for watching.